All right, here we go. Ready? We're going to SCAD this whole thing. We're going to make sure that our people at home can see it as well. Ready? Here we go. Set up right here in your setup. In your setup. This is where I list what I'm doing, okay? I'm doing a sampling distribution for X bars, not P's, P hats. I'm doing X bars and Mu's, okay? So I'm doing a sampling distribution, which they're all called sampling distributions, but I'm doing it for X bar. And now let's just list everything that I know, okay? So I know that my mean is 1. I know that my standard deviation is 1. And I know that my N is 70. And I know that they want me to test, is 1.1 hours sufficient, or do I need to do 1.25? There's pros and cons. 1.25 would always give them enough time, but it might give them too much time. They might be twiddling their thumbs and going to Starbucks, you know what I mean? Okay. Plus, if you have 70 to maintain, 70 AC units, then you might want to get them hustling and do 1.1, right? But then, could you imagine if you were the technician and 1.1 wasn't quite long enough, and then you would be frustrated because you were always behind. And to me, that would just kill my soul if I felt like I was never on time anywhere, you know? All right, so this is what I'm looking at, okay? So I know my sample size is 70, and so the central limit theorem applies, but I'm going to go ahead and write down all of your conditions. So now that we have that, now we don't have that many conditions. C stands for conditions. There we go. Okay, conditions. Same one that we had before. This is our independence condition. Capital N is greater than or equal to 10N. Okay, so N stands for all of our, what are we looking for here? N is 70, so we have 10 times 70, and this is all AC units. And would you imagine that that would be greater than or equal to 700? Yes. Again, I've never really seen this one where I haven't said yes, okay? It is one of those independence rules. You've got to have independent SRSs. So this is one of those that you can pretty much, we don't assume, but we can conclude, yes, we have met that. The population is greater than that. My other one, so this one, here's number 1. Y'all can call them rule of thumb, whatever you want to call them. And then number 2, this is my easy one. This is my normality one. And yes, this is different than my P's. Thank goodness, okay? My sample size has to be N, has to be greater than or equal to 30. I love this one. It's easy, right? And I've kind of talked to you about 30 before. So, yes. What if I do not meet one of these conditions? Proceed with caution. There's going to be more variability in your answer, and your answer could be off, right? If you don't meet the normality condition, bless you, but then you end up doing a Z-score over here when you're not even sure if it's quite normal yet, then you could be off, right? Okay? Continue to proceed if they ask you to proceed, okay? All right, so set up conditions. My next thing is arithmetic, and our arithmetic is our Z-score and our P-value. Isn't this easier than the P's and P hats?
Yes.
So much easier. You know why today's a good day? When I came in this morning, pumpkin waffle candle, Walmart, great value. When I came into school this morning, I had to throw everything out in my refrigerator. It was a bad day, right? I could have made that a bad day. Perspective is I had enough money to go to Walgreens and get some caramel macchiato. So it's all about perspective. All right, here we go. So my X bar, I have to do 2 different ones of these. Let's go ahead and start with 1.1. Be careful. Remember, if you don't have a fraction bar, you need to group these together with parentheses to make sure you're getting the correct Z-score. But y'all know that I love this calculator, so use your little bitty Algebra 2 calculator, Algebra 1 calculator. middle school calc. Did I do that right? Yeah. All right. Tell me what you got for your z-score. Round to 2 decimals?
0.84.
Perfect. 0.84. Okay. Does that seem very unusual to y'all? It's not too bad, right? Okay. All right, so here we go. We're going to look up 0.84, and we're going to see what percent of the time, because we're looking at a p-value, what percent of the time will I be able to finish in 1.1 hours, right, with these 70 machines. So here we go, 0.84. Did you get 0.7995? Now, how many of you are like, I don't know what that 0.7995 means? Okay, so it may have helped if with this, I drew a picture. I know the average is 1, and then I know that I'm testing an X bar of 1.1. So where should I shade on this? Like, what would make sense to shade?
Below.
Or not, okay, maybe. Yeah, I guess we could do below. In this situation, it would be fine. I usually look for the extremes, but yeah, okay. What is the chance that I will be able to complete a job in 1.1 hours or less? Sure. And what did we get? So 79.95% of the time, I should be able to. So now my decision comes about, and I'll use that 79.9. All right, so 79.95% of the time. Did y'all get that? Okay. The 70 AC units should be completed by in 1.1 hours or less. But now we have to look at the flip side of that, right? That's 80% of the time. So how much are you going to be running behind? How often will you be running behind? Right? Like 20% of the time. Like, I would be okay with running behind 5% of the time, but maybe not 20% of the time. Okay? All right, so yes, go. So now we're about to do 1.25. So we did test 1.1, and it said, do you want to budget 1.1 or 1.25? So now we're going to go back, and we're going to do 1.25. Okay? So now I want to see what 1.25 looks like. So I'm going to squeeze a z-score in here. And we're going to try that one out. And I love it on these calculators because I can just go back and I can, you can highlight what you put in there, you know, and then just reach and change it. All right, what did you get for the z-score for this one? 2.09? Okay. Now look up 2.09, 2 standard deviations away. 0.9817? All right, so if you budgeted an hour and 15 minutes, right? An hour and a quarter. If you budgeted that much, then 98% of the time you would be able to complete the jobs. Okay, so I would also need to write a decision for that, right? So 98.87% of the time jobs could be completed in 1.25 hours or less.
So quick question, but
Yeah.
would you do it more like 1.25, then wouldn't the technician be kind of like, they get done early, they'd be wasting a lot of time?
Absolutely. So this right here, just having this data right here would make you start considering what would be best for your company. So this would work for your brother. He's got 70 lawns out there, right? And he knows on average this is how much time it takes. He doesn't want people twiddling their thumbs. If you can get an extra lawn in, get an extra AC unit done, then I want you to get it done because time is money, right? So, so this would be a very interesting thing to do. Now, when it comes down to it, this is somebody else's decision to make, okay? So you might want to find something kind of in between here, right? In between 1.1 and 1.25. Maybe 1.1 is not quite enough. 1.25 is too much, but now we did the data to support it. So I'm not just saying, oh, I'll give you 2 hours to do everything every day. You get 2 hours. You know what I mean? And you're not just wasting time and money. So me, I'm on the conservative end. I'd probably go here because I would hate to feel like I was running behind all the time. But then again, you might be wasting time over here, right? Because again, you might be twiddling your thumbs in between 1.1 and 1.25. So that would be a toss-up, and that'd be your decision if it's your business, okay? But now y'all seen this SCAD. Are y'all good? Okay, I'm done. There you go. All right, turn this off. Bye, sugars.